Okay, so in week 2, question number 1, we're going to have the study or the phase diagram. I think that you remember what the phase diagram is. We said that if we're going to have an alloy consists of multiple metals, then we're going to have multiple melting points. We're going to have multiple uh, solidification points, and that's going to be represented on what we call the phase diagram. So we can have the solidus, which is the solid state, we can have the liquidius, and we can have the mixtures in between. Today we are going to have two examples. The first one is determining the compositions from the phase diagram. So it's required to illustrate the procedure. Suppose that one wants to analyze the compositions of the liquid and the solid phases present in the copper-nickel system at an aggregate compositions of 50% nickel and the temperature of 1260 degree or 2300 Fahrenheit. So we need to find that. Now all the lines are there, but we are going to go in steps to see how we can find that. Okay, so once again, in the phase diagram, we have the, well, actually, I should get my laser pointer here. So we have the solid state. This is solid state. That's anything below this line is going to be called solidus. Above this point, we're going to have liquidius when the two metals are going to be melt. In between, we're going to have a mixture of the lower melting temperature metal to be melt, while the other one is still solid. So we're going to have the mixture state. Now you can see these lines. I'm going to show you the temperatures of 1260 degree, and we have some lines and show you the percentages. So let's have a look about how we can solve that. So it's solution hints. What we need to do first is sketch a horizontal line at the given temperature. Now we have 1260 degree, so I made this red line. You can see that it's going to be intersect with the liquid line and with the solid line. Now the line intersects and the solidus line at a certain composition of a nickel. You can see that this is the line, that's a solid line. The composition I got for the nickel is 62%. 62% nickel. Now, this indicated the composition of the solid phase. At this temperature, 62% of the nickel, okay, have the solid state. Now we go to the next step, the intersection with the liquid state. The liquid state is going to represent 36%. So the intersection with the liquidius indicates the composition of the nickel corresponding to the analysis of the liquid phase. Now, a horizontal line is going to be drawn at the given temperature as shown in this level. The line intersects with the solidus composition nickel is 62%, thus the indicating of the composition of the solid phase. The intersection with the liquidius occurs at the composition of 36% of the nickel, corresponding to the analysis of the liquid phase. That's the solution we have for this question, 36 and 62. That's the percentage of the liquid nickel and the solid nickel, and the liquid nickel at the temperature of 1260 degree. Now, as the temperature of the 50% copper and nickel alloy is going to be reduced, the solidus line is going to be reached at about 1221. So you can see that I made the line here at lower level. That's the 50-50, as you can see here. 50% nickel, 50% copper. So the temperature is going to be 1221. Now, applying the same procedure, that's what we're going to have for the intersection with the liquidius. And that will be the intersection with the solidus, which is going to be 50%. So applying the same procedure using the example, the composition of the solid metal is going to be 50% nickel, and the composition of the last remaining liquid to freeze is going to be about 26% nickel. Okay, so that's it. That's the answer for this question. The intersection of the liquid is occur here. Okay, 26%. With the with the composition of 36% nickel we have here, okay, corresponding to the analysis of the liquid phase. So that's what we are going to, that's how we're going to use this diagram. Now we would like to determine what will be the amounts of each phase, and we can do that graphically by finding the distance LC and the CS. That should be done graphically. Remember that I have the diagram available for you in the first page of the tutorial session. So you can print that, you can work on it, use the ruler to make the measurement, and let's see how we're going to use this one. So the amount of each phase present at given temperatures from the phase diagram can also be determined, and this done by using the inverse lever rule. First, using the same horizontal line as before, that indicates the overall compositions at a given temperature. Measure the distance between the aggregate compositions and the intersection points with the liquids and solids, identifying the distance of the Cl and the Cs respectively. So we just set the temperature, make the line, intersects, that's the 50%, that's the LC distance, that's the CS distance. We just need to measure them by using a ruler, for example. So the proportion of the liquid phase present is going to be given by the. We can also use the phase diagram to determine the amounts of each phase. And this can be done by using the graphical method. We're required to find the value for the distance of the LC and the CS. So the amount of each phase presents at the given temperature from the phase diagram can also be determined, and this will be done by the inverse lever rule. So using the same horizontal line that we sketch at a certain temperature that intersecting with the liquidus and the solidus, and we have the 50-50% line to be sketched here, we're going to have three sections, the LC and the CS. So we need simply to identify these distance, and then we can apply the following equation. The proportion of the liquid phase present is going to be given by the equation that liquid phase proportion is equal to the CS distance divided by the LS distance. Third, the proportion of the solid phase present is going to be given by the distance CLC or CL divided by the total distance from L to S. That's it. Now let's see an example on that. So let's have an example to determine the proportion of the liquid and the solid phases for the 50% nickel composition of the copper-nickel system at the temperature of 1260 degrees. So we sketch a line. Now we have the LC and the CS to be measured. So using the horizontal line in the figure 6.2 as the previous example 6.1, the distance of the CS and the CL are going to be measured to be 10 millimeters and 12 millimeters respectively. Okay, now we know this distance, we just simply apply the equations. So the proportion of the liquid phase is going to be 10, which is the value for the CS, divided by 22, which is the CS plus the LC. And this will give me 45% as a liquid phase. Definitely, we can say that 1 minus 45 is going to be 55%, or you can apply the equation for the solid phase, and this will give me 12 over 22, and this will be equal to 55%. That's it, and thank you for your listening.